And just to remind other people who are watching this live or not live, is that Kspir is a cloud-based web application that where each party involved, like an owner operator, the EPC, and the manufacturers, will have their own login and with their own tailored view of the platform. And here today we'll be logging in as a demo owner operator. And yeah, as you can see, we start with a dashboard that has all the project information, the project milestones, and we've covered in our previous webinars all of the functionality of the core module and as well as the material master and data governance modules. And today we will be focusing on the M-BoM module. And yeah, like Peter said, the first thing that you start off with is that after you've sent out your spir documents, you've created your tags, you also need to create your functional locations. There is a lot of variability in the industry between company to company in terms of what is a tag and like the differences between the terms tag, functional location, equipment. And in our particular case, we're describing a tag as a serialized unit of an equipment, and they are being linked to a separate record that is a functional location. And just like everything in our system, functional locations are controlled via specifications. So you would have your functional location specification, like let's have a look at this very basic, for the demo purposes, specification of a seawater pump. You would set up a tag you would set up a criticality for it as some sort of a short description, and then once you can then create your functional location records, and then you can start assigning tags to it. So in this view, we can see that, for example, we've linked this electric motor and a centrifugal pump to the seawater pump. And now we can go on to the second tab where we can have a view of all of the tags that you have across all of your spir documents, whether they are already linked to a functional location or not. And they are assigned different criticalities based on their functional locations. So for example, you can filter all of the highly critical tags, well, locations and the associated tags, and then you can start going through them and applying your maintenance strategy in implementing it directly here. So we are doing this by assigning critical failure repair code and return to service codes. And the codes are something that is a product of a long time of work of Peter's.
Yeah, so I'll jump in here, yeah, just to help explain. So as I said earlier, that the what we try to do here is to codify. So what you can see in the first response R01, it's a failed unit that's replaced with a new unit by your own labor, and the old unit is scrapped. So we've got so you know the unit's failed. What you're doing, you're replacing it with a new unit, who's doing it, and what the outcome is, and all this is codified in a unified way, and this is part of your decision-making process. If you know these three things, then you know the next part of, and you've got some other information. You start to build up what happens, what we call what happens in the event of failure, and you start to build up the responses to it. And as you see all this build up, what you see then is that not only does it's open, transparent, everybody knows what needs to happen in a particular location when an event happens, but it means that you could, as we go back to the decision support system, if things change, then you can change these parameters, and again, people will know. They just have to look up the system. So the next part of it is the return to service. Now, this depends again. If you've got a duty and a standby and a pump, it might be that you're happy for that pump to run for 6 months on the standby, and you don't need it back, and so you can have the priority. So what you've got here is an emergency priority, an urgent priority, a high priority, a medium priority, and a time frame. All these codes are configurable. You can change them to suit your own needs, but they're all based on on experience. We're done with multiple owner operators and with many experience. I've been very lucky to work with lots and lots of really good reliability and reliability maintenance engineers who have given us lots of advice on the sorts of scenarios that exist in the real world, and it was a lot of the work that I've done in the past, bringing all these things together, because this is what's lacking, is this bringing together of the different parts. So back to you, Alakan.
Yeah, thank you, Peter. That was very insightful. And if we go on to this third tab, we can see that here is where you actually start assigning and creating bills of materials for. So firstly, you select a functional location that you would like, and then you can go through the tags that are assigned to it. And you can see here that on the left, obviously, you see all the properties and values of both the functional location and the tag. And on the right here, you see a list of maintenance bills of materials that you have assigned to this. So you can create and customize them however you want. There are categories and subcategories. And in this particular case, we are using 14224 for this, ISO 14224 standard, that is. And I think Peter can, again, jump in here and describe a bit more about the different categories.
Yep. Okay. So yeah, ISO 14224 is an ISO standard, as Alakan mentioned, and it's for the collection and exchange of reliability and maintenance data. And what it has in the document, it has all the various scenarios that you want on lots of different types of equipment, the boundaries for them, the types of failure that they occur. So what we're starting to build up here is we're starting to move on from the original spir document, being able to create the bill of materials. And to answer Jonathan's second question, isn't the spir just a bill of materials? This is why it's not, because you have lots of different scenarios, you have lots of different types of failure, and you need to be able to build up different types of bills of materials to cope with all that. And so you can see in the categories there, you have corrective. These are the categories that ISO 14224 use, two basic categories, and then subcategories. So you have intermediate, you have immediate action, and you have deferred action. So what you can see here is that from the preventative side, you have vibration monitoring. And what we might be doing is that you might have a schedule of vibration monitoring that tells you you're going to have a bearing failure either immediately or in 6 weeks' time. But if you've got a bearing failure in 6 weeks' time, you create a deferred process and a deferred work order, and you bring all these bills of materials into all that. So this is the way of combining all the different techniques, all the different types of maintenance activities that you carry out, and defining what sort of spares you need to execute that maintenance routine. So that's what we're happening here. As I say, it has all sorts of equipment boundaries, all sorts of failure modes and effects analysis within 14224. We use that as a basis for this. Clearly, not everybody uses that standard. There's lots of other maintenance standards that people want to use, or it has developed their own, and you can apply those equally as well into this system. Back to you, Alakan.
Thank you, Peter. Yeah, let's just jump in and have a look at how the actual BoM looks like. So if you click on this one, this is a bearing failure M-BoM, and here you can see that you have a list of your spare parts against the tag in this functional location, and you can see that you can start going through them and assigning this M-BoM quantity, which essentially means that, okay, how many spares do you need of this particular, how many of this particular spare do you need to perform this maintenance task? So for example, in case of the bearing failure, you obviously need to replace the bearings. However, one key thing that manufacturers don't know that we allow you to see is that once you've assigned your critical failure repair code, so for example here we can see that we said that, okay, this failed unit is repaired offsite by specialist labor, and okay, that means that clearly we're not going to repair it on site, and we're not gonna do it ourselves, so there is no need to actually keep in stock any of these spares for this action. And this immediately solves us buying all of these. And one other thing to note is that if you have a data governance module, you can also have your material masters linked directly to your spare part. So for example, if you click on this one, you can actually see that this material master is linked, this spare part is linked to this material master. You can see that its current status is in sync. And obviously, so when something happens, you can look up a functional location, you can select the tag that you would like, see the list of, out of the list of bills of materials that you have, see what happened, choose a specific one, and then you can easily identify it and find it in your stock. Another thing is that you can also see the original spare document that the spares are coming from. So if we click on this one, then you will be able to see the actual spur documents and all the spur lines. And for all of our new viewers, this is how a spur document looks like in KSpur. This is your familiar spreadsheet structure, but brought into the 21st century, so to speak. We can see the additional features like potential duplicates and like more advanced deduplication, as well as you can embed material specification into this, and you can see this characteristic data, completeness score, and both this actually and all of each part of this, the spare document, the tag details and the header are configured via specifications. So like I've shown you at the beginning, the functional location, you can also do the same for the spare part, for example, details, and you can configure all the properties that you need, the lists of values, the representations and units of measurement. And also important to know that everything here is a concept. So if you click on this one, you'll be able to see all the alternative terminology, the abbreviations, and very importantly, definitions, which allow everyone to know what everyone is talking about. And
so
yeah,
Atakan, can you do me a favor and go back to the where you're allocating the spares codes? There's a very important principle here, that one of the principles of this is that if you just drop down a list here, what you'll see when you drop down the list, some of the codes start with C and some of them start with NC if you scroll down. So that simply stands for critical and not critical. And the principle here is if the item isn't critical, you shouldn't be buying the spares. And that's what the coding tells you. So what the spares coding is telling you, which is the supply chain response to the demand, is whether you should hold the spares, where they should be held, and who owns them. Because it's not necessarily that even if you hold the spares or that you own them, and it's not necessary that even if you don't hold the spares, you don't own them. So there's lots of different combinations that we've taken account of here, and that's very important. That what we're doing here, as you can see, this is the supply chain response to the information, and what is brilliant about the way we brought all this together, we can see all this in one screen. As I mentioned earlier, you can't do this sort of analysis on what your spares response is without seeing what your demand is, and that's, it is a complex process, as we've explained a number of times. But by bringing it all together into these screens, you can now do the analysis in a way that's not been possible to do in any other way. So we're very, very proud of how we brought these screens together. We understand they're complex, but it is a complex process, and actually I haven't seen anybody else that's bring all this information together into one screen. So we think that's very, very important, and that's why, as Jonathan said earlier on, we believe that we're leading in this field from what we've seen of our competitors.